David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember that you can slow down or speed up the playback if that helps you follow along. Second, you could turn on the captions and watch my words go by on the bottom of the screen. And lastly, you can pause the video at any time to catch up with your notes or think about the topic. Today's topic involves problem solving with the sine and cosine rules. So problem solving, another word for that is word problems or story problems. So these are problems that present you with realistic situations where you have to use geometry to figure out the answer to the question that's asked. So we're using the sine and cosine rules in this one. I have my diagram here, and then I have my text. Word problems almost always come with text. And part of the challenge with a word problem is you have to read the text, figure out what they want so that you answer the right question. And believe me, I've seen people do word problems where they did the math 100% right, they just didn't answer the correct question. So let's get started. A helicopter flies at 125 miles an hour, so pretty fast, and it needs to go directly from Green City to Cedar Falls. How long will it take? Now, a word problem like this is going to be accompanied with a diagram like this one. And basically, you have a map view. We're looking down. This is like a map. And here's Green City, and here's Cedar City. So, and then these lines are roads. This is US 81, straight up and down road. And then this is a county road that goes straight for here, and then it gets all wiggly. But the segments that we need to look at are straight. So that's going to help us use our triangle geometry here. The diagram has given a little bit of information. This distance here from Green City to the junction is 85 miles, and the distance from the junction to Cedar Falls is 94 miles. So we know those two distances, and we have this angle, the angle that these two roads make with each other is 112 degrees. So that's helpful. Okay, now let's look back at the problem. A helicopter flies at 125 miles an hour and needs to go directly from Green City to Cedar Falls. So check this out. I'm going to draw on my diagram. And that's the way the helicopter is going. Okay, so it doesn't have to stick with the roads. It can go straight there. So we want to find out how long does it take to go from here to here. So a rate problem, if you're trying to figure out the time, you need to know the rate and the distance. And we'll get to that in a minute. But right now, we just need to find that distance. So here's where you can pause the video for a minute, think about the sine and the cosine rules, and figure out what you might need to know to find that distance. Okay, so to find this distance, I could use the cosine rule. Because if you recall from the cosine rule, we can use two sides and the angle in between them to find the length of the third side. So I'm going to first write up the cosine rule, and then we'll do a plug-in step, and then we'll find our distance. So the cosine rule was a squared equals b squared plus c squared minus 2bc cosine a. And the way to think about this is the opposite side equals the two other sides squared minus 2 times those sides, that's BC, times the cosine of the angle that's between them. Okay, so this is an application of the cosine rule to find a squared. So a squared is that distance. So let's go ahead and do the math on that. That's going to be a squared equals b squared. I'm just going to pick one of those. That's 85 plus c squared. That's 94 minus 2 times 85 times 94 times the cosine of 112. Kind of ran out of room there, but I think you can see what I've got going on. Okay, now I want you to pause the video and get out your calculator and crunch the numbers, and let's see if you can find A. All right, let's see how you did. So the way I like to crunch this one is I like to do the two numbers that are just simply squared. I square them and I add them up, and I get that number. Then I do this chunk over here, the 2 times 85 times 94 times cosine 112. And I have to remember that that negative comes down, and then if this term is negative, I'm minus a negative. So these four things multiplied made negative 5986.2. I'm going to subtract that. I've got two negatives, so I'm adding. So I get now my a squared equals 22047.2. Take the square root of that, and my a is 148.5 miles. So now we do our reasonableness check. Does that make sense on our diagram? And indeed it does. If that's 85 and that's 94, it makes sense that this would be 148. It's the biggest side of our triangle, and yeah, that makes sense. Okay, so I'm going to have a question for you. Have we finished the word problem? No, we have not. What does it ask? Go look at the problem over there and figure out what it asks. Okay, if you figured out, we need to find out how long it takes. You're right. So we have a helicopter that goes 125 miles an hour. We've got to go 148.5 miles. So what I want you to do is pause the video and do that calculation. All right, when I do that, I get 1.19 hours. Now, is that how we measure time? If I were to ask you how long does it take to fly there, you wouldn't say 1.19 or 1.2. Actually, let's call this 1.2. Let's round that. So that's 1.2 hours. We would say how many hours and how many minutes, or how many minutes total. So I'm going to ask you to pause the video and convert that for me. All right, let's see how you did. To find out how many minutes 0.2 hours is, we just multiply 0.2 times 60 because there's 60 minutes in an hour. So 0.2 times 60 is 12. So that means this flight is going to be 1 hour and 12 minutes. All right, let's do a more complex problem. This is going to require a lot of thinking, but I'm sure you can follow along, and please try when I say pause the video and do something, really give that a shot. Okay, so let's take a look at our problem. It's just right over here. I've got my diagram here. I've got a horizontalish line cruising along like that, and then I've got three sloping lines that all end at point D, and they come down and they hit our horizontal line in three different spots. We're also giving you some angles. This angle here is 28. This one is a little bigger at 38, and this one's a lot bigger at 77. Here's a distance. You're given that this spot there is 32.8 degrees, okay? Now, here is what we have to find out. Find DC, which means find the length of DC. I'm going to go ahead and put an X at that, right there. So we have to find X. That's our X. So take a minute and stare at that picture and see, maybe copy it into your notes and see how you might approach this. And then I'll come back and we'll talk about the overall steps, and then we'll execute them. Okay, now here's the thing. We have only one length given to us. So we're going to have to start in this triangle with the length. If we don't have any lengths, sine rule, cosine rule, all those things, they're no help. You need a length to get started. So I have a length here. So that means I can start saying things about this triangle, and I can use those things to maybe move from this triangle into that triangle. If I learn some things about this one, then I can probably figure out a way to find out what X is. But this might actually be maybe a three-step problem, 3 different calculations required to get to finding out what my X is. So let's get started. Taking a look at this first triangle, this ADB triangle, see if you can come up with something that you can write, some kind of an equation. And I want to kind of mention before I turn you loose, we got one side and one angle. Not enough. I'm thinking probably sine rule, but maybe cosine rule, but regardless, I need 3 things to use either one of those rules. Now there is a thing you can get pretty easily, but you have to see it. So pause the video, think real hard, see if you can come up with that thing. Okay, so to get another angle, I can use this 38 over here, because this plus whatever that angle is has to make 180. So that means this angle here is 142. That has to be 142. And now I can figure out, now see, my side here, that's not opposite of either of those 2 angles. So if I'm going to do like perhaps sine rule, I need to actually figure out what theta is, which I have conveniently marked here perhaps as a little tip. So if you'll recall, theta is easy to get because each triangle, the interior angles always add up to 180, and I know 2 of them, so I'm going to have to be able to figure out the third one pretty quickly. So 142 plus 28 is going to give me 170. I need to get to 180, so theta is 10 degrees. And you can check that on your calculator. In fact, if you're doing this problem, I recommend you do that. 28 plus 142 plus 10 should end up being 180, which it is. Okay, so now in triangle ADB, I can figure some things out because I know two angles and one side, so that means I can figure out another side. Now, which side should I go for? I can figure out this side if I want, or I can figure out that side. Now, if you recall, we're trying to move that way through the diagram so we can figure out what x is. So I'm not going to bother figuring out what AD is. I'm going to figure out what BD is, okay? Because that's going to get me closer to my goal. So let's check this out. Sine rule is side over sine of opposite angle equals the other side over the sine of the opposite angle, etc. So let's see if I can write one. I have this angle and this side, and I have this angle and I want that side. So what I can write here is 32.8 over sine of 10. That's this side over the sine of the opposite angle, and that's going to equal this side, which let's call this y. That's going to equal y over the sine of 28. So I can just write that here, y over sine 28. I need to get y alone to find it, so I'm going to cross multiply this one up, and I'm going to get 32.8 times sine 28 over sine 10, and that's going to give me my y. So go ahead and pause the video and give that a try. Okay, I get 88.4. Now let's do the reasonableness test. Does that make sense? I only have one other measurement to compare it to, and that's this 32.8. So 88.4, yeah, that makes sense. This could easily be 88.4, so I feel good about that. Let's mark it on the diagram. 88.4. Okay, so I've made a step. Now I'm trying to get all the way over to this side, right? And I'm not there yet, but I'm pretty close. I just need to do one more calculation. This was our first calculation. We just need to do a second one. So no 3 calculations like I said before, but just 2. Okay, so now look at this triangle, BDC, and see what you might need to do to figure out how to calculate this length here, x. And you're going to use a trick that we used in this other triangle to do that. Okay, check it out. Remember how we figured out what this angle was because we knew this plus this has to be 180? We can do the same thing here. This plus this has to be 180. So that tells us that this has to be 103 degrees. It just has to be that. So now we've got a side we know and 2 angles. So we have 3 things, and we can use those 3 things to find a 4th thing. In this case, it's going to be my x. So pause the video and write a sine rule equation that includes the x and the 3 things you know, kind of really similar to this first equation that we wrote up here. So give that a shot. Okay, let's see how that goes. I'm going to do side I want, this is the unknown, over sine 38. So that's going to be x over sine 38, and that's going to be equal to, now I know this side and this angle, so I can do 88.4 over sine 103. So there's my sine rule equation. Now I need to get x alone, so I'm going to cross multiply the sine 38 up, and I'm going to get x equals 88.4 times sine 38 over sine 103. So now pull out your handy dandy calculator and do that calculation, and let's see what you get. All right, I get 55.6. So now let's do our reasonableness test. We had, this is 32, so this should be bigger. And yeah, it looks bigger. This length is definitely bigger than that length. And then we also got this one. This is 84. Now this one has to be shorter because we've come in a little way. So this line is shorter than my 84. So yeah, it makes sense that this is 55.6. So there you have it. Woohoo! Now that you've watched the video, jot down a couple notes so you can ask questions at our next class. Remember that you can also watch the video again just to deepen your understanding. Lastly, if you enjoyed the video, please click like and subscribe.